Welcome, Gus.
Yes, I can see me now. Hi, everyone.
Hi, welcome. We can hear you.
Nice. That's very good. Hope everyone's having a great day.
Yes, we are. Please take it away.
Nice. Hi, everyone. My name is Gus. I'm from the developer advocate team from Tensorflow, just as Lawrence and Josh. I'm trying to keep up the pace, but it's very hard to follow them because they're great, but I'll try my best here. So today I'd like to talk to you about on-device machine learning, what it is, when would you use that, and some examples in the wild, and what can you do with it, right? So let's go right now. Oh, if you want to follow me on Twitter, it's at Gustema. I usually share knowledge about machine learning, Python, and TensorFlow, of course. So if you have any questions, just follow me and ask them. I'll try to answer. Let's try to understand what's this edge ML explosion. So the thing is, first we start with machine learning, and it's cool, and you can solve a bunch of very good, nice problems like vision, text, and others. But then that was so good that people thought maybe we should use that on other place outside of our servers. And how can we do that? And when people found out that you could run a model on a device, that changed a lot of things, right? Because then you have a phone, and everyone has a phone, and maybe you can use the machine learning model on pictures from your phone. So that's a huge thing that you can do now. It completely changes. And then what happened is that the phones start to have more and more hardware to support this journey. So now they have specific chips to help with machine learning. They have more memory, they have more processor power, they have more space. So this is making easier to deploy a machine learning model on the on device. And there are some other parts that we should pay attention. When we want to run machine learning on device, we are worried about some other things that the device can do. One of them is a lower latency. So for example, if you want to get some insights from an image, the old way or the regular way, right? It would be like you take a picture, get this image, upload to your cloud server, run the machine learning, no matter how fast it is, and then you send back the results. No matter how fast your server is, it will still take the round trip to take the image there and get the result. And this is definitely this will definitely take longer than one frame in a video, for example. So if you want to do this with lower latency, like just look at an image and a result, or apply that for every frame in an image in a video, then you cannot use the cloud, right? You have to use something closer to you, which would be your own phone. So if you want to do that, that you can only do that on the edge side, as we say, right? The other thing is sometimes you want your model to don't rely on network connectivity at all, or maybe you are in a region that the network connectivity is very bad, you're far from any antenna, any Wi-Fi, anything. So you want for your prediction models to keep working, keep giving you predictions. So for example, if you have a camera that does some fancy processing during taking a picture, and then you go for a hike in a mountain or in a forest somewhere beautiful, but then you need the connectivity to take a picture, right? To help you with taking this picture, and then you have a problem, right? When we start to run on-device machine learning, we are trying to also hide that, to run everything offline, everything completely local. When you do everything completely local, you can preserve privacy of your user. So you don't need to upload your user's picture, your user's data to anywhere. You can just run everything locally. So in terms of privacy, this is way better. So you can guarantee your user, look, I'm just working on your image locally, giving you insights. Nothing is going out of your phone. So this is another advantage of running things on device. And doing that, you are creating a new generation of possible products, some things that weren't even possible in the past. Now you can do them just because of this power, right? So let's see some examples. Here we have YouTube. YouTube has one feature, let's say, that allows you to try makeup right in the app. So there's a YouTuber presenting, oh, there's this makeup here. If you want to try that, those are the colors, and then you can just use right locally. This is the kind of thing that's you cannot do that with the cloud, right? Because for each frame of the image, if you upload to the cloud and come back results, it's not real time anymore, so it gets a little bit clunky. So this enable this kind of feature, and of course Google Translate. I'm pretty sure most of you have seen that. So what Google Translate does is it uses OCR, as you can see on the little video there. It's using OCR, extracting the text, and then translating to the language that you selected. In this case, it's English. So the thing is, it's more than one module here. So there is the OCR module, there is the translate part of the model, and use both of them to give you a result. This is something that's was completely unthinkable in the past, right? Because everything is running completely on device locally. That's why it's so fast. How do we do this? And then the next question I have is, okay, I agree with you, Gus. This looks like a good idea, and you should. But how do we do that? How do we get there? And this is where we have TensorFlow Lite. So TensorFlow Lite is the framework to deploying machine learning models on mobile devices and embedded systems. It's not only Android. We are going to see there are a bunch of devices that we can use here. And this is the same framework from TensorFlow, but it's a version that's created to run on device. And this has some, there's some points you have to pay attention that takes into that account why this is special, why it's different. So we are going to go into all those details. Among the devices that the TensorFlow Lite platform supports, we have, of course, Android and iOS smartphones. We have Linux-based devices like Raspberry Pi and other dev boards that we're going to see in a little bit. And we also can run that on controllers, like Arduinos. And let's see in more details how it works on the phones. Today, there's thousands of products already that are running machine learning on device. So of course the Google ones, as we all know, YouTube Assistant makes a lot of sense, and then we have other developers that are also using machine learning for multiple use cases. For example, some use cases might be related to here when we are on a video conference and you want to blur the background, right? Here I'm not blurring my background, but some video conference apps allow that. This blurring is running machine learning on device locally. And for example, if there was captions, closed caption on what I'm saying, also machine learning running closed captions locally. We have Gboard there, for example. Gboard tries to find, if you swipe on it, it knows which words, and these statistics of the words and how to get there, they are all based on machine learning and running completely on device, right? So your data doesn't go to any cloud, it's just local for you. Aside from that, TensorFlow Lite can help you in all kinds of tasks in machine learning, not only image, because we talk a lot about image, I guess because that's the simplest example we can come up with. But it also works for text classification, prediction, for speech detection, but we talk about the closed caption, right? That's a speech recognition, image with a lot of kinds of tasks into image, like object detection, image segmentation, facial modeling, and so on and so forth. Of course, audio, if you want to track audios, and also if you want to generate content, if you want to generate parts of a video, generate text. And so TensorFlow Lite can help you in all of those tasks. And if you need some examples of what's available already, we have this web page here, which is the main examples page for TensorFlow Lite models. What you find there is the problem. Like, for example, there's image classification. There is a source code for samples for Android, for iOS, sometimes for Raspberry Pi too. It's explaining how the source code works, explaining how the model works, and it gives you everything so you can learn from there easily, right? So this link is kind of important if you want to play more with TensorFlow Lite, and you should. So this is one thing. The other library that can help you is MLKit. MLKit is it's a library over TensorFlow Lite to help you apply machine learning on device. It has some already pre-created use cases that will help you, and with these use cases you can already easily, you don't need to worry too much about models or TF Lite or anything. You just use the API. That will make your life easier, but it's all based on what TF Lite is doing already. And if, for example, your use case that you want to implement is not there on MLKit, you will need to fall back to TF Lite as usual. Does it make sense? Is it considering anything? Okay, no, someone connected. Let's see how it works with Linux-based devices like Raspberry Pis. We have our friends from Ecovacs, and they have this vacuum cleaner, right? These robot cleaners, and they are using machine learning on these devices to detect things and avoid hitting obstacles while cleaning the room. And this is a very nice example, right? We would expect this kind of robots to see if there's anything in front of them and take another direction, change, don't hit anything, right? So this is a very nice use case. Aside from that, we also have something called Coral, which is a streamlined version of what TensorFlow Lite can do. And these models, they run on a chipset called Edge TPU. And these are, as you can see, there's a coin there. So chips are super, super small. And TF Lite models run on this chip super fast. And this is something that can enable some way more use cases than only on the phone, right? Here we have some examples where you can find these Coral products. For example, we have a dev board if you want to create something, create a product. And the cool one I like is that USB accelerator, which is like a pen drive, but you have an Edge TPU inside of it, so you can connect on the USB port of your dev board or any Raspberry Pi device, and you can run your model on this, and it will be super fast. Even if your Raspberry Pi, rest of it, it's just not as advanced, this will help you run models like you can do frame by frame on a video, for example. That's very good. There's some other hardware. I'm not going to go into too much detail on them right now. Let's talk a little bit about microcontrollers and what they are. So first of all, let's try to understand what's a microcontroller. Microcontroller is kind of a computer in a single chip. So if you think about that, that's like the smallest piece of computer that you can have, and they are available they are already deployed in multiple things. For example, on a refrigerator, microwave, smoke detector, toys, multiple sensors. So what TensorFlow Lite enables you is to run machine learning on these devices. And some of these chips are absurdly fast for specific kinds of mathematical operations. And when they do that, they can run models absurdly fast if you know how to do that. TensorFlow Lite gives you access to that, even though they have, of course, not as much memory or processing power as a phone, and they use way less energy, less power. So they have a lot of advantages here. And even if you think you're not using any DSP already, you are kind of are, because when we do hot word detection on Pixel devices or other phones, what they do is they are running this model for keyword detection on the DSP of your phone. Your phone has this kind of chips too. And because they use so not that much power, they are very good on conserving energy. Keeping a model running on it all the time doesn't spend too much battery of your phone. So that's the way we can do hot word detection on a phone and just say keyword and the phone wakes up. So it's because some specific chips are monitoring the audio of, it's not non-stop, there's some algorithms there, but they can, he said okay Google. I don't like saying that because then all my phones, they wake up. So if you say okay Google, they will, the assistant will come up, because the DSP is waiting for, as I said, the DSP is waiting for this kind of instructions to, hey, someone is calling here, and then it wakes up the phone and gives control to the proper processor to continue from there. So the model that does that is way smaller. It's not like a speech detection one. It's a keyword detection, which is way smaller, much simpler. So this is how these kind of things would work. So if you want to play with that, right now there's an official Arduino library, and there is a 5 minutes speech detection tutorial that you can follow. There's a link over there. There's thousands of possibilities here, and running machine learning on super small devices, that's some very cool things. I've talked to you a lot about how to run these models on the device. And then you're thinking, yeah, but what's the drawback here? If people say, oh, you need a lot of machines and processors and memory to do all of this, how can it run on the phone? Where there's something missing here? And the point that's very important, when we aim to run models on edge devices, we call edge devices the one around, right? Mobile and Raspberry Pis and all those that I mentioned, is because you have to work on this model to take into account the hardware constraints that you have to face. So let's take a look on that. First of all, optimizing your model is very, very important. The same model that runs on a server might not work at all on a phone. And we are going to see some examples here. Because first of all, you have limited compute power. No matter how amazing is your new phone, it's still not as fast as a server, right? That makes a lot of sense. You don't have that much memory. Same thing. No matter how advanced it is, not the same as a server. And the other constraint that phones and edge devices have is they have a battery that they have to be conservative about it. They cannot, oh, let me just keep running this nonstop. The battery run out of power, and then the user cannot use the phone anymore. So this is a problem. You have to pay attention to that. And there's the app size. If I give you 1 gigabyte model to run on a phone, and then a 1 gigabyte model to just run your phone, the user might look and say, no, I don't want this app anymore. It's like too big. Like this is too much. So app size is also very important. So how can we address these constraints with our models? So first of all, there is some things we can try to do here. Let's go one by one. First of all, when we deploy a model on the edge device on a phone, there are you should use one model that's optimized for a model for mobile architecture. So you don't use a model that's optimized for a server. You use a model that's optimized for a phone, for a Coral device, for a microcontroller. Those models, they take a lot into account already to make it fit inside like a phone. The other thing is you can, after you have your architecture that's compatible with a phone, you can apply quantization to it. I'm going to come back to that. What's quantization? And you can apply also something called pruning. I'm coming back to that also. And the last one is leverage hardware accelerator. And that's using the special hardware on your phone to help you do the inference in real time. Let's go to optimize architecture. So here I have two examples. On the left, we have Inception V4, which is a state-of-the-art model for image classification. This is a big model that runs on servers. It's amazing and all. We have also the MobileNet V3, which is kind of super new, and it's, as the name says, focused to run on on-device machine learning. And here we start to see some amazing things. First of all, the top one accuracy for Inception V4 is 80%, and for MobileNet V3, 75%. So you're talking here about almost 6% difference. So your mobile model is 6% worse than the top model on servers. But let's take a look here. 80% is amazing. So if the computer looks into an image, it has 80% kind of 80% chance of telling you correctly what's in the image. When you go to the phone, it's 75%, which is still great, super good, right? When we talk about top 5 accuracy, is I will return you 5 things I think are on the image, and of course this is the accuracy here is higher, right? Because I have 5 options to find out what it is, and for on device you can see that's 92. It's still great, right? If you're, for example, if you have a app that the user looks into a picture and you want to give tags, like this is a picture of pets or has a dog, and then you can help the user categorize their pictures, right? Returning a top 5 accuracy, all 5, and then the user choose which category he wants, that's huge, right? That's very good UI. That's very good use case. And with 92%, it's still super great. And now we can see the super advantage here. When we run Inception V4 on TF Lite, it takes 320 milliseconds. That's like eternity in phone's perspective. But when you run that, when we run the MobileNet V3 on the same framework, it takes 8 milliseconds. So this is 37 times faster. And the 8 milliseconds, if you think about a video or the rendering pipeline of phones, they render a frame every 16 milliseconds. So if you can do inference every 8 milliseconds, you can run inference for every frame on a video, right? So this gives, you can run on a video, inference on a video and do way deeper analysis there. While the Inception V4 take a couple of minutes, not minutes, but it will take a long time to finish one execution, right? So this is a huge difference, and you have only 6% difference in accuracy. So that's good. And the other super advantage is the Inception V4 is 170 megabytes of size, while MobileNet V3 is 22 megabytes. It's almost 8 times smaller. So look the difference here. This is big, right? And this is how we use a proper model architecture to help. Here we have a graph with a lot of state-of-the-art models, and you can see that, of course, the smaller the model, it has less accuracy. There's no magic there. But you can get to a compromise that's good for you, that has a very good accuracy with not that big of a model. So this is just to highlight that. Let's talk a little bit about quantization. So if you think about what a model is basically a very long equation full of floating numbers. That's basically what it is. And then when you load this equation with TensorFlow Lite, what it will do is it will get the input, apply to that equation, and get a result. The thing here is this, for every a times x plus b times x1 plus c times x2 and so on and so forth, all these a, b, and c, they're float numbers. And float numbers take a lot of space. And one thing that researchers found out is you can decrease the float32 to an int 8-bit size number, and you won't lose that much accuracy at all. So I forgot the English word for that. Sorry. Completely forgot. So taking this decrease in accuracy, it's super valuable, and this is something that makes models much smaller, and you don't lose too much accuracy. Let's take that. Here we have a good example. We have 3 examples of models, and we have the accuracy of them. And then we have the float version, the float32 that I just mentioned. And we have on the side, if you do the quantization to integers, you can see that you lose like 1.5% in the first one, but the other is like less than 1%. The last one is not even 1%. So you can see that you can make your model way smaller and you still have a very good accuracy. So quantization is your friend, and it will help you with deploying models. Also pruning. If you think, I guess Lawrence and Josh mentioned, like you're creating a network, right? Like a graph. What pruning does, it goes over some of the weights of your model, and if they are too close to 0, they just make them 0, and then they remove them. Of course, you are removing information from your model. It will definitely get less accuracy, but the how much less we are going to see in a little bit. But the idea is you make your model smaller. When you make your model smaller, it will run faster, so because it will load faster, and it has less, let's say, items in that very long equation I mentioned. You're removing some of those because they are very close to 0. They might not affect. So pruning is very important. And as I said, smaller models, it's easier to compress them. They have less complexity inside of them, and they since they use less operations, they of course run faster. And here we have an example, right? So we got a model. I don't know if the name of the model is MobileNet. So we got MobileNet accuracy, which is and so the accuracy is the y-axis, and the how much pruning we are going to do is on the x-axis, right? So here for 50%, so we are cutting 50% of the variables, let's say, from your equation. You've got negligible amount of accuracy drop. You can see that's very, there's not much at all, like it's less than 1%. And if you start to cut more and more of these nodes, your accuracy starts to drop until up to a point where it drops too much, right? So pruning is an amazing thing to help you make your model smaller and faster. Now let's take a look on all the results at the same time. First of all, if you run your model on device only on the CPU, this is for the MobileNet V1, right? It's a model that the architecture is already focused on device, focused for running on device. It will take 37 milliseconds. 37, not great. You cannot run every frame. If you quantize the model and it still runs on the CPU, remember, CPU is not specialized on running machine learning models, right? It will drop from 37 to 13 milliseconds, which is, it can run every frame now. So the quantized version of the same model, it's already almost 3 times faster. If you run the same model on a GPU, you are almost double the performance, right? You go to 7 milliseconds. And the thing is, you just, for TensorFlow Lite perspective, it's one line of code. If the model is compatible with GPU, which it probably is, you just say, okay, use GPU. That's it. And then you get 7 milliseconds. If your phone or your microcontroller has an edge GPU, it goes from 7 to 3.2 milliseconds, which is super fast. This is absurdly fast. And if you have a Hexagon DSP, remember I mentioned DSPs? So Hexagon DSP, some phones have that. And you can, same thing as GPU, enable. Just say, run on DSP. You go to 2.8 milliseconds to run an image classification model on your device. This is super fast. And this is based on multiple optimizations that comes way after you train your model, right? So you get your data, train your model, blah, 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 blah. From the moment you convert to run on the phone, this is when you start to look into this part of the playing around, right? So there's kind of some work to do here, but you can see that you can do great stuff. I'm not going to go into too much more details. There's a lot to talk about when we talk about TensorFlow Lite, but I just want to give you an introduction of what's on-device machine learning. I hope it was useful and that you got some ideas and want to play around with that. Follow our tutorials, our guides, explains everything. We are always working to make this easier for all the developers. So yes, follow up. There's the documentation there, tensorflow.org/lite. And again, thank you very much for your time. I hope you enjoyed. If you want to follow me, I'm on Twitter. Yes.
Amazing. Thank you so much, Gus. It's been a long day for many of us. I know it's quite early for you. But we have a few questions which we're going to pop on the screen. I have some, but I'm going to put Nuruddin's question. How does pruning differ from dropouts?
Dropout happens during training. So if you have a layer that's a dropout, you're doing kind of a pruning during training. So your model learns how to adapt that during training. Pruning is after. It's when you have your model already, and then you look into the weights and say, oh, these weights are too close to 0, I'm removing them. So it's on 2 different stages of your model's life, let's say.
Absolutely. So this is very important for our region. There's a lot of work going on with access and devices, trying to find the $30 price point for a mobile device, for a smartphone in sub-Saharan Africa. What are the hopes, or what are the opportunities, or what are your views of the $30 smartphone being able to run TensorFlow Lite and do many of these on-device machine learning tasks?
Of course, there's a challenge. You're not going to be able to do the same thing as a Galaxy S. I don't know, their top phone. You're not going to do the same super real time on a very large image. But if you're working on a smaller image to do some, for example, there is the detecting disease on plants, right? This is a very common use case. You don't need a high resolution image to do that. Of course, with a higher resolution might be better, but you're not going to do like I want 99% accuracy. No. You want to take a look and understand how things are going. And some models you don't run on real time. You run on the background. So you are processing like a text, extracting some entities from there, or you're understanding audio. So this is completely viable to run on devices that are cheaper, let's say, right? With lower hardware power. But you can also use the Coral devices I mentioned, or the Raspberry Pi. They're cheap. They're cheaper. They're not cheap. They're cheaper. And depending on what you're trying to do, if you want to monitor, I don't know, your crops, you put some of those devices that can cost maybe $1 a device. Of course, I know it's money. It's not free, but it's way cheaper than a phone. And then you can still run your module and get some readings from your crops, from, I don't know, forest, from other things that from your car. If you want to, for example, people can run these microcontrollers on your car and detect when it's going to break. So it can monitor your engine, say, oh, your engine is not going well, maybe you should do something. You put a microcontroller there to try that. So there's a lot of opportunities here.
Yeah, and then my final question just has to do with computer vision versus things like natural language processing, especially voice. A lot of the people in this region probably don't speak English as a first language. So things around translation and understanding voice commands is also going to be very important. Is it more difficult? Because I've seen a lot of your benchmarks have to do with vision and stuff like that. Is it more difficult to do computer vision, or is it much more difficult to do things like natural language processing and have this happen on the device?
So they have two different problems here. The problem with the vision models are easier to understand. So that's why we explain a lot visual problems, because they're easier to understand, and the models that we can explain, they are easier to understand also, right? And there's a lot of data. When you go back to text, there is two problems with text. First, understanding text is harder from machine learning perspective. It's more advanced, so you need to understand more machine learning. And as you said, there's the language problem, right? For example, I speak Portuguese. My main language is Portuguese. If I want to do a model for Portuguese, I have to find out a database of Portuguese speakers, which is not as easy as an English one. So there is the problem that the model is more complex, and that finding a proper data set is also not as straightforward. And the same for audio. Audio has a lot of data sets, but maybe not for the language we want, right? So this is, there is pros and cons as easier and harder on both of them.
Awesome. I really want to thank you very much for joining us. Like I said, it's been a long day, and we expect a lot of people are going to watch this like as a recording. So if there are any questions, we'll come back to you through your Twitter handle, or if anything gets funneled to my email, I'll be reaching out to you directly to provide answers directly to people.
Of course.
Thank you very much, and we hope when the world returns to another normal, you will make the journey to come towards Africa, Nigeria, Mozambique, Angola. We've got Portuguese-speaking countries here as well.
Yes.
So we're looking forward to hosting you on the continent 2022 or 2023.
Let's hope so, my friend. Let's hope so we can see each other in the future.
All right. Bye for now.
See you later.
Bye.